Okay. Let's see how you guys can listen to me right now. It's pretty cool outside, and that's how I'm going to start um, this series of, I guess you could call them episodes. I am going to teach you guys about what I know about physics. I used to have a physics website, but it got torn down because of certain situations that happened to the ISP server, and so now it's not longer online. But I'm going to teach you guys about gravitation, and more than that, what I found out after I discovered this theory of gravitation, that many other things started fitting in. So gravity was like a nice, I guess you could call it a nice frame. You know, if you're making a puzzle and you create this nice frame first before you start putting all the other puzzles together. Once you put the frame in, everything comes right in very easily. So that the frame was gravity, and once I created that, everything else started fitting in really nicely, and that is went all the way to how the universe is born, what the Big Bang is. So I want to teach you all that to you guys. For example, right now we think that nothingness and something is actually very different. Like something can never come out of nothing. And when it comes to evolution, you have to understand that something had to have come out of nothingness, because eventually it's like who came first, chicken or the egg? The first thing that was nothing. So nothing became something, and I think it's a cycle of nothing becoming something, and then something becoming nothing. What I'm trying to say is, let me put it this way. If I take the moon, all right, and I compress it to its ultimate state, it will become, from matter, it will become nothing. It will become like a ball of nothing, like about this big or something like that. About this big, a ball of nothing. That ball will have space and time space in there. And the time space in there will be a lot slower than the time space here. So if you live in there, minutes that go in there will be like equals to hours here. So not only that, it will have such a huge, powerful gravitational force that it will plunge into the planet. And let's say if it's not planet Earth, let's say some other things like planet Jupiter. Well, it will plunge. If you plunge it into planet Jupiter, it will start eating planet Jupiter all the way up, and it will start growing. What you have there is just a small, what we call black hole. I call dark collapsed star. So in order to make nothing out of something, you have to take something and crush it, reduce it, compress it to its ultimate state, and there you have nothing. Now if you want to have something, then you have to crack nothing. You have to crack nothingness. You crack nothingness with a huge, the only thing that can happen, that you can crack it, is with a huge, gigantic energy, like a vibration. It's like if you are living inside a piece of glass, and the glass is transparent, and it's just a metaphor. You're living in a piece of glass all your life, and you see nothing. And then somebody comes from the outside and takes a little, I guess, a small ice pick, and just hammers your cube of glass, and so all these little pieces come out, and you got yourself little pieces out of nothing. That's matter. That's just a way of seeing it. We think of nothingness as being nothing, but nothingness is actually the compression, the full compression of something, the full compression of matter. When you compress matter to the full compression, it becomes space and time. So I'm going to teach you about many things. I'm going to teach you about that. I'm going to teach you about how why the universe is oval in shape. I mean, I can show you that right now because it's easy. First of all, we are living inside what we call a black hole, what I call a dark collapsed star. Collapsed stars tend to get compressed to its ultimate state, so they turn into nothingness. They sip matter into nothingness from outside in. And they're sipping matter from outside in, turning matter into nothingness. They create this gigantic wave. And this gigantic wave, once it reaches the center, okay, there's an explosion in the very center because the compression is so large and so powerful. Only a tiny little piece of that dark collapsed star gets an explosion. So this is like in the world, a guess of mine. If the dark collapsed star is this big, okay, and it collapses all the way in, turning matter into nothingness. Once it reaches the center will be so small, the explosion there will be so small that I wouldn't be able to see it with a naked eye. It would be that small. However, that would be the Big Bang, and the universe would be the whole entire universe would be right in there. And okay, why the universe is oval in shape? Imagine a dark collapsed star collapsing, okay, collapsing to its ultimate state. Before that, it used to be a large star, and large stars get banged all the time with huge matter, like planets and major dust. And if they pick something up and it starts banging them at a specific place, they because of gravity, because of the force of gravity, and the bang coming this way and this way again and this way again, just matter, like big matter, like the size of planets or big rocks, and they start just collapsing against this large star. The star begins to move faster and faster and grow bigger and bigger. So imagine a star that is moving, okay, not so fast, but relative to its size, not so fast, but it becomes a supernova, and all of a sudden it becomes like this small. Imagine how fast that object will be going, okay? It will be going really fast now. That would create such a gigantic, powerful centripetal force that the star will no longer be oval, will no longer be, nicely, round shape. It will be oval in shape, but it's spinning like crazy, okay? So imagine a dark collapsed star, black hole, let's say, spinning like crazy, and all of a sudden it starts collapsing, all that matter into space. The collapse happens in an oval manner. So when you get the Big Bang explosion, the Big Bang explosion will also be in a collapse, in a oval-shaped matter as well. But if it's oval in shape this way, when it explodes, it will be oval shaped this way, because this part here and this part here, when they meet, when the explosion happens, this part here is the closest one. So this is going to be the first part of the bang, and this one is going to be the last part of the bang when they meet in the center. Okay. This part will crack nothingness first, and then will be followed by this one. So when the explosion happens, the explosion will be distorted. So the universe that it creates will be also distorted, will be oval in shape this way. So dark collapse star will be like this, and the Big Bang universe, the universe created by the Big Bang, will be oval shaped this way. Okay. Now, one thing I want to know that you guys want to know. Well, if matter comes from nothing, well, because of black holes and the things that we know about black holes, we don't have learned about black holes, we know then that matter becomes nothing. But since the universe is also very unstable because of the Big Bang, that creates a kind of a like an aftershock that has been here all the time, all since the universe was born, and that aftershock causes the nothingness of the universe to expand and contract. And when it expands, it creates kind of temporary matter. And when it contracts, the matter disappears. Okay? That's when you do experiments, you find that matter and antimatter actually appears in the vacuum, and then it disappears. Because that space expanding and contracting. I will show you how I came to that and many other things when it comes to the gravitation theory. I placed an equation that you can see that gravity is the process of acceleration, and acceleration is not what we think. We think that acceleration is going faster, getting in a car going faster. That's not really what acceleration is. That is a byproduct of acceleration. But guess what? A byproduct of acceleration is also getting slower. Is getting faster and also going slower. It's basically changing the state of speed that you're in relative to the space outside. In other words, it's actually collapsing relative time-space, and that is what makes us change the position of speed relative to the objects on the outside of us. And it's something that I'm going to get into. It's a bit difficult to understand, but once you get it, because the mind doesn't understand reality. The mind actually is evolved to understand the perspective of reality, not reality the way it actually is. So when you understand reality the way it actually is, it's kind of different. It's really different. So, like acceleration is not going faster. Acceleration, you can go faster, and acceleration you can also go slower. An example is when you get into a car and you accelerate, you go faster, and you get the force of gravity. Since you're collapsing relative time-space that way, you get gravitation going that way, so you feel the pull of gravity this way, getting to the back. Now, when let's say you reach 50 miles an hour and that speed is constant, when you see a red light and you put the brakes, okay, there you start slowing down. Now you think that you are not accelerating, but guess what? You are. You start accelerating backwards, trying to catch with the passing road. Because of that, now you're accelerating that way, you're collapsing relative time-space that way, so you get gravity going this way. So you feel the pull of gravity going this way, like that. And you're accelerating, and yet you're slowing down relative to the road. So acceleration is not what we think it is. Acceleration is the collapse of relative time-space. Whenever you collapse in time-space, you get acceleration. And you can get acceleration by matter occupying space. It distorts relative time-space by occupying space, which is what we are right now, gravity. And also, when you are, or when anything runs around in a centrifuge manner, You also get gravity there. It's the same exact equation. You are actually distorting relative time space, making it short in one end and longer in the other. So gravity flows towards the larger end. And when you accelerate in a car, you also do the same thing. They are all the same because they all feel the same and they all do the same exact thing, which is they all collapse time. They dilate time. You put a watch inside a centrifuge, it slows down. You accelerate in a car and time also slows down. However, it's more difficult because you can't be accelerating all the time because you reach a point that it's going to be, very fast, and you're not going to be able to you're going to have to be able to slow down. But if you go fast and you slow down, you go fast and you slow down, you'll be, also reducing time. The reason why you don't reduce time that much is because it's the collapsing is not that big of a deal. So you get 0.0000000. I keep going zeros, 5 of a second. So you don't notice that. But when you are in a centrifuge, you can go crazy with a process of acceleration because you can increase the g's to a ridiculous force that if you were in it inside that centrifuge, you could die because it would be really incredibly powerful. And because of that, you notice time slowing down there a lot better if you had a watch, especially if you had an atomic watch. And the same thing is with gravitation here. You have gravity, okay, and you have time dilation. Time over here is a little faster than here. Here is a little faster than here. Here is a little faster than here, and so on. You have a time dilation. That is what that is created by the distortion of relative time space. And every time you get, so the equation is this, is simple. Once you got it right, once you understand it, it is gravity is the process of acceleration created by the distortion of relative time space bestowed upon by matter. Let's say that again. Gravity is the process of acceleration created by the distortion of relative time space bestowed upon by matter. That happens when you accelerate in a car. That happens when you're in a centrifuge. That also happens when matter occupies space. Now I'm going to show you all of that, and I have my papers, which I'm also going to put so you guys can take it, just pause the video and perhaps read some of it if you don't understand what I'm saying. But I'm going to be as clear as I can. And if you understand the whole thing, you're going to see how everything fits, all the way down to how matter becomes nothing and how nothing becomes matter. It's like a cycle. Nothing, matter becoming nothing, nothing becoming matter inside dark collapsed star. From there, other dark collapsed stars are made right in there, which create nothingness, and they create their own big bangs in there, and then you go right inside there, and it's just the universe are inside other universes, which are inside other universes, which are inside other universes, and it just continues to get smaller and smaller and smaller, but only relative to the universe on the outside. That's the thing. Time space, whether it's large or small, is actually the same. It is only when you relate size to another size. But the universe that is smaller inside the other universe that is larger, the same equation is happening in there. That universe is as large as the other one. That the small universe is as large as the other one that's larger. But when you relate the universe as larger to the universe as small, then the large one is larger than the other one, which is small. In other ways, size is relative, just like motion is relative. Okay, that's what I'm trying to say. So you can go in and continue going in and continue. How in the world can you do that? How in the world can something go inside itself and continue going in and in and in and in forever? Yet I can actually pass my hand, my finger through nothingness and just finish what could be. If it's infinite, okay, and it's infinite, well, I can pass right through infinity and just end it. See, I passed right through infinity and yet I just ended it. So how in the world is that possible? The human brain doesn't understand that, but there's a way to understand it. Okay, say I have a ball, okay, and I throw that ball, and I throw it really far, okay, and when I throw that ball really far, let's say that I throw it out in space. I'm in space and I throw it out in space, and it is going to go on forever, because motion is relative. I threw it at a certain speed and it's going to continue going that speed forever. Okay, I will explain how that happens if you guys understand that, which I hope you do, because I hope I hope you already have a good knowledge of physics. By the way, I'm dressed like this because it's really cold outside and it's really cold here because I don't have my heater on. So I'm not going to be dressed like this all the time. Anyways, this is not like a trademark that I'm putting. Okay, so I throw it out into space, and it begins getting smaller in my eyes. It begins getting smaller and smaller, going that way fast. The more further it goes, the smaller and the smaller it goes. Smaller and smaller it turns. It gets so small that then I'm going to have to use a telescope. Put the telescope, and then I see it, and the ball is this small, and then still getting smaller. I have to get a bigger telescope, get a telescope, and now it's this small, but then it continues getting smaller and smaller. I get a bigger telescope, and I see it getting smaller. Get a bigger telescope, see it getting smaller and smaller. Then I run out of telescopes, and when I see with my naked eyes, it's totally gone. It just doesn't exist here anymore. It doesn't exist. What is there? That's the same thing that happens when universes go inside, universes go inside, universes go inside, universes. It just it's no longer there, but it's there. Now the brain is not able to understand this. I'm not able to understand it, but I know that if another can go that way and disappear, it can go this way and disappear as well. I believe. I mean, I think. There's no other. You can go smaller and smaller and smaller and just continue going smaller and smaller forever, I think. But relatively to what I think, I may be wrong with it on this, but it's I don't know. It's just too. Everything I know tells me that is the way it is. I mean, it can get smaller and smaller and continue getting smaller and smaller forever. It's just that it's not. Mind is not able to understand it, because I guess infinity is also a relative factor. It can be something can be infinite in a certain space, and it cannot be infinite in another certain space. It can have a beginning and an end, but with that beginning and an end, there is infinity. And that's another thing that I'm going to talk about, because this is one thing that a lot of us don't know about, and that is that dimensions don't really exist. We might think dimensions exist because we're taught dimensions existed, but dimensions don't really exist.